This is the angle, sine inverse, negative 2/3. Okay? So the other angle that has sine negative 2/3 is going to be over here. Would you agree? Okay. So how do I get that angle?
Something minus something.
Pi minus that, okay? Because this is going to be a negative angle.
Plus 2/3.
This angle is going to be pi minus sine inverse negative 2/3. It'll always work like that. Whatever you get for the sine inverse, the other angle that solves it is going to be pi minus that sine inverse. Okay? How did the cosine work? Remember how the cosine worked? On top half of the circle, that was cosine inverse whatever, and then the opposite of the cosine inverse whatever. Okay? So now, what's the period of this function? This equation? Well, it doesn't matter, the period of these equations. Because whenever this is true, whenever sine x equals negative 2/3, this equation is true. Okay, so what's the period of sine x equals negative 2/3? What's the period of that equation? How often does that happen?
Every
2 pi. Every 2 pi. Period of sine x, right? Period of sine x. So that means my solutions for over here are x equals sine inverse negative 2/3 plus what? Plus multiples of 2 pi. And then for the blue one up there, pi minus sine inverse negative 2/3 plus multiples of 2 pi. Okay, 2 pi n is multiples of pi. 2 pi, sorry. Alright, what about these solutions? What do they give me? Plus what? 2 pi n. And
minus.
there you go. Okay, looking at this. How many solutions? If I was going to graph this on an interval of 2 pi, how many solutions should I see? I should see 4. Once you graph this equation, everything's set equal to 0. Wait a minute. Right here is what I want you to graph, the blue one. Okay? I will go down so you can write that. But I want you to graph that, and I want you to graph it on an interval from 0 to 2 pi and see there's 4 solutions. Those are the